Okay, now that we've talked about how to simplify complex fractions without variables, let's look at some examples with variables. As mentioned in the previous video, one method would be to get a common denominator in just the top fractions, or the fractions in the numerator, and then get a common denominator with the fractions in the denominator, get a single fraction divided by a single fraction, and then divide. So looking at these numerators, I see x minus 1, x plus 1. These are different factors. There's no way to turn this x minus 1 into x plus 1. There's no way to turn this x plus 1 into x minus 1. You cannot distribute a negative and ever make them match. So don't try to do that. So our LCD for the fractions in the numerator would be the whole thing, x minus 1 and x plus 1. Looking at the fractions in the denominator, it's the same thing. So x minus 1, x plus 1. Now it's possible for these LCDs of the fractions in the numerator and the fractions in the denominator to be different least common denominators. Now we need to make these fractions have that least common denominator. So the fraction here on the left in the numerator has the x minus 1 in its denominator, but it doesn't have the x plus 1. So I have to multiply by x plus 1 and x plus 1. Whatever I do to the numerator, same thing the denominator. Now the second fraction has the x plus 1. It doesn't have the x minus 1. I'm going to do the same thing there, numerator and denominator. Then, looking at the fractions in the denominator, they had that same least common denominator, and we need to make those match. So the one on the left has the x plus 1. I need to add the x minus 1. The one on the right has the x minus 1. I need to add x plus 1. Alright. Now each one of these is a binomial times a binomial. So we have to multiply all of that out. Looking here at the x minus 4 times x plus 1, you can FOIL or box it out, but you need to make sure you're multiplying it all out completely. You'll get x squared minus 3x minus 4. Okay, so you can check that by foiling or boxing it out over the LCD. That fraction minus, now we're going to multiply x plus 5 times x minus 1. When we multiply that out, we will get x squared plus 4x minus 5 all over the LCD. Now, I'm going to do the same thing in the denominator. So those were just the fractions in the numerator. In the denominator, now I'm going to multiply x plus 4 times x minus 1. We'll get x squared plus 3x minus 4 all over our LCD, plus our last fraction here, x minus 3 times x plus 1. I'll get x squared minus 2x minus 3 all over our LCD. Now the whole goal of that was to add or subtract and get a single fraction in the numerator, single fraction in the denominator. When I subtract, I have to be super cautious that I am subtracting all the terms in that numerator. Subtracting x squared, subtracting 4x, subtracting negative 5. So let's go ahead and combine those into a single fraction. X squared minus x squared is gone. That's 0. Then negative 3x minus 4x will be negative 7x. Negative 4 minus a negative 5. Remember, when we subtract a negative, is the same thing as adding. So negative 4 plus 5 will be positive 1. Still over our LCD. Then in the denominator, same thing. Combine our like terms. X squared plus x squared is 2x squared. 3x minus 2x will be 1x, or just x. Negative 4 plus a negative 3 will be negative 7, again over our LCD. So I have a single fraction in the numerator and a single fraction in the denominator. I could rewrite this as the division of two fractions. I'm going to go ahead and write it out in one go. So negative 7x plus 1 over our LCD. This is the first fraction times the reciprocal of the other. So x minus 1, x plus 1 will go in the numerator, and 2x squared plus x minus 7 in the denominator. Then from there, we need to factor as far as we can. I'm looking, these are already factored. Here, the only thing I could possibly take out would be a negative. And then in the last trinomial here, I would need something that multiplies to negative 14 and adds to 1. However, the only factors of 14 are 1 and 14, or 2 and 7, which can never add up to 1. So this is prime and cannot be factored. Once everything is factored, we divide out any common factors. So x minus 1 divided by x minus 1, x plus 1 divided by x plus 1. We multiply anything that's left and end up with negative 7x plus 1 all over 2x squared plus x minus 7. You could factor out that negative if you wanted to, but it would be equivalent to this. Go ahead and try the examples on the right, or example. Okay, looking at this example. Again, our goal is to get a single fraction in the numerator, meaning they have to be combined using a common denominator, and a single fraction in the denominator. Looking at the fractions in the numerator, we have a y squared and a y in those denominators. So the least common denominator of the fractions in the numerator would be y squared, right? We take the one with the highest exponent. Looking at the fractions in the denominator, the LCD of those two fractions would be x squared. So now, this fraction on the left already has the y squared. I need to make this denominator y squared. I multiply numerator and denominator by y. In the fractions in the denominator, the first one already has an x squared. I need to make the second one an x squared. So I multiply by another x, both the numerator and denominator of that fraction. Now I rewrite them. So x over y squared minus y over y squared, right? 1 times y. In the denominator, we have y over x squared minus x over x squared. Now I can combine them into a single fraction, x minus y over common denominator of y squared. The fractions in the denominator are y minus x over x squared. Now I have a single fraction divided by a single fraction. We can multiply by the reciprocal. Copy the first fraction exactly as is, multiply by the reciprocal of the second. Now when I look at these, I'm thinking these are very similar. X minus y, y minus x. They're the same terms, but with different signs. So I think if I could factor out a negative, then I'll have a common factor that I can divide out. Let's try rewriting it. We'll leave this one alone. And then in the denominator here, we'll take out a negative 1. That will change this negative x to a positive x, and this positive y to a negative y, right? Divide out negative 1. Then I have x minus y divided by x minus y, and I'm left with x squared over y squared, and I have this negative 1, so a positive number divided by a negative number. Overall, there's only one negative, it will end up negative. You could leave it in the denominator, leave it out front, or put it in the numerator. You're going to end up with the same thing.